Uh, so today's session is about multi-section digital axial counters. Yesterday we have studied about the single section digital axial counter. They are now today is the multi-section. Who we are expecting is to attend this, that new beginners who wanted to choose signaling as career, and the students of signaling who are under training already, and some working signal engineers with 1 or 2 years experience, and experienced working signal engineers who are already working in some other fields but wanted to know this modern signaling system. So today's session contents are, we will talk about data communication a little, and then architecture of MSDAC, and then look at the various makes of the MSDACs. The idea is to make you comfortable when you look at the detailed installation manual or the manuals of these particular makes. You feel as if you are looking at it the second time. So that is the idea. So data communication takes place in two ways. One is depending on the data type, vital and non-vital. For example, electronic interlocking, giving its internal data of the state of change of the signaling elements to a data logger, that is a non-vital. So it is given through a non-vital port. Then if two electronic interlockings are connected by a port, like distributed electronic interlocking, they are connected to the vital port. Physically, port may be same, but the data exchange is taking place with a safety critical norms. For example, like same electronic interlocking connection to its SMS VDU or the maintenance PC, they're all non-vital ports. How the MSDAC and let us say electronic interlocking are going to be interfaced? There are two ways. One is physically through the relays. Second one is through the data. The first one, you can see MSDAC can have two outputs per section. Basically, one is really taken to the electronic interlocking, but both also are used actually. That is vital relay, which says that the section is clear or not. Preparatory, that is under the reset. So those relay contacts are wired to the electronic interlocking. Similarly, when one of the sections there is a problem and then the reset has to be done, that is given through the electronic interlocking. There is a facility to do it independently also. There is an interface available separately for MSDAC, but if you want to do it through electronic interlocking, it can be done through electronic interlocking, which gives a relay output, and that relay output is contact is wired to the MSDAC. And down below, what you are seeing here is the MSDAC is communicating with the electronic interlocking through the data in the data form. So nothing is, no visibility will be there. And the serial interface ultimately works out cheaper, and they would be more reliable because the wiring is in the relays, and then relay wiring is avoided completely here. Now, a lot of data exchange takes place in the multi-section digital axial counters. So Ethernet and CAN bus are some of the things. Like SSDAC, MSDAC is also a SIL4 product. There is RDSO specification 176. And also for all electronic equipments, there is a specification 144, which talks about the safety and reliability requirements, which is made exclusively for the Indian Railways by RDSO. But generally, all the MSDACs are adhering to the SEN-like standards. It is compulsory actually, because to get the SIL4 certification, safety assessment is done based on these 4 types of standards. First one talks about the reliability, availability, maintainability, and safety, how it is done. And second one is about the software design. And third one is about the hardware and software together when they are working, mainly the hardware point of view also, how they are taking care of the safety. Fourth one is it is related to the communication. If the communication is taking place between the 2 systems by exchanging of the data, how it happens in a fail-safe way. What are the processes that are to be ensured? For example, if one MSDAC is communicating with another MSDAC through a E1 channel or an optical fiber cable or a copper cable, now the cable cannot be said it is fail-safe. It cannot be said it is fail-safe. It can have all types of faults. It can touch the other conductors. It can break. It can have earth leakage. All those conditions shall not cause any safety implications when data is exchanged between these 2 systems. That's what actually safety-related communication means. Now, the MSDAC system basic parts, if we look at, we can see the blue box. In this, there is a rail contact, and then there is a digitizer that is called counting point. The together rail contact and digitizer together are called counting point, or detection point, or DP. Different names are there. Now, the digitizer gives the wheel counts to the evaluator, and multiple number of these wheel rail contacts or counting points, they send their data to the evaluator, and the evaluator, based on the configuration of the detection points, it checks for presence of axles within that area, and then gives a decision as an output. For that purpose, multiple processors are used to ensure the safety. That we will just are going to look at it a little later. Now, yesterday we have seen the single section digital axle counter. What is the difference between the 2? You can see in the SSDAC, the electronics is hardly 5 meters from each wheel sensor, 5 to 10 meters. And then the counts are exchanged between the 2 evaluators. And the relay is available at both the ends. If you look at the MSDAC structure, the wheel detection counting points, the electronics can be available separately by the track side, and the evaluator can be a common one at a central place. And at a given station, there can be more than one number of units. That is the axle counting unit actually. So MSDAC special features are more track sections to monitor with more wheel detectors, and the distributed power supply. Power supply has to be distributed because the counting points and central place, they are all separate. Then data exchange takes place between wheel detector and evaluator, and between evaluator and evaluator. So these both things happens. For this purpose, data communication network has to be set up for this purpose. And there is analog signals exchange also, that is transmitters and receivers. Ultimately, it is the physics, electrical signals that transmitter gets the certain signal and it is influenced by the wheel, and a receiver says that how it is influenced, and both these are processed by the wheel counting unit. This is the pure electronics, and then some data is generated out of it. This output given by the MSDAC is a potential free contact or data. Both are possible, and most of the things nowadays available are with potential free contact, but slowly they are upgrading to the data exchange also. This is it. If we consider this yellow unit box as the MSDAC, and it gets the input from wheel detection points, multiple, and then resets. Resets here are given not by providing a voltage, by potentially free contacts, and internally reset takes place. No voltage is given from outside for the MSDAC like in SSDAC. And communication with the other MSDACs also connections would be there. These three are the network connections. And then output is potential free contacts like this, and port to give the data. We can see the circuit here, how these two potential free contacts are used. Like let us say 24 volt DC supply through a fuse is connected. These 4 dots are the connectors of the output for the MSDAC. So 24 volt DC externally through a fuse comes inside and proves a contact and comes back to the relay coil, and then negative path also it is proved. So for vital output, 2 contacts are provided by the MSDAC. You can see a diode here. The diode is connected in the opposite direction of the positive thing. You can see this is the how it is connected. The purpose of this is to, when this particular relay is dropped, let us say the contact is opened because of the output is not available because of the condition of the interlocking, the naturally vital relay drops. When the vital relay drops, it gives a kickback of a voltage of almost up to 600, 500 volts for a few milliseconds. And if that is applied to the output terminal here and here, it can enter inside the MSDAC and damage the electronics. That is why that pulse is, and that pulse is in the opposite direction of this 24 volt DC. Because if this is the plus and this is the minus, the generated voltage minus is here and the plus is here. Because of that, the whatever pulse generated is dissipated inside here itself, like this in the circle. Another way of looking at it, there is a wheel sensor and about 5, 10 or 15 meters coils with track side wheel electronics. And then there is a cable for data and power to carry to the central place. And at the central place, there can be some electronics, some wheel sensor electronics, which converts it into the data of wheel counts and pushes it to the processor. This processor can be 2 out of 2 or 2 out of 3 architecture. Like this, the number of wheel sensors sends the data to this. Based on the condition of the wheels counts, track section vacancy is detected and it sends a message or a packet data form to the output. And the output card can create a potential free contact, which is fed to the interlocking system. So this is one way of understanding. Still further, we can see one more pattern. I am repeating it because it brings out the various features. This is also same. There is a wheel sensor and there is a cable, and then wheel sensor electronics There is an input and then output, and it is brought to the evaluator, and evaluation is done, and evaluation gives output in the form of data or potential free contact. Here the thing is, different models, different manufacturers followed the same process, but realizing the product is done in a different way. Say, for example, some of them, the whole electronics is kept inside the wheel sensor itself. There is nothing, there is just two wires connecting evaluator to the wheel sensor. That's all, nothing else you will see outside. And some makes, they have wheel sensor, they have some electronics here, and some more electronics are related to the input here. So this 4A, this 4B are very relative actually, that some electronics can reside in the wheel sensor, some electronics can reside in the central place at the evaluator. Now this communication media also, it can be a copper cable or it can be OFC also. Now coming to the signaling side. To monitor the track of a given yard, we have to finalize first the position of the DPs. How we have to do it is just similar to the track circuit. But there are some advantages of the axial counter compared to the track circuit. Like for example, point zone. If you try to include 2 or more points in a single track circuit, the series bonding becomes so complex that there can be failures which cannot be easily attended. Whereas here, for that purpose, track circuits are split actually. Instead of one track circuit, 2 or 3 track circuits are made. In case of axial counter, there is no such need actually. We can include a large number of points, large number of DPs to form a single track section. So we can have even one detection point. Let us say a dead end is there with a shunting facility. Just at the entry of that dead end, we can keep one wheel sensor, which can say whether there is any wheel available inside that or not. So even one detection point can detect or provide an output. There is no need for the 2 detection points. Similarly, in a straight line, 2 detection points are used. Then 3 or 4 detection points are normally done at the point zone. And multiple detection points are required for ladder networks, which I will be just showing to you. And in auto section, consecutive single sections are required. And supervisory track section also is one of the application where the reliability of the track section monitoring can be improved. This is how, for example, you can see this is the ladder of points. There are about 15 points or so, or 16 points. Now, by providing wheel detectors like this 1, 2, 3, 4, like this 16, 1 to 16, all complete thing can be made into a single track circuit if the interlocking allows it. Not naturally, it should allow. Other than that, yes, maybe one more DP can be kept here to make it 2 sections so that mainline, if we consider it as a mainline, train can pass on this. Similarly, different combinations. Here, it is made into 2 sections actually. And you can see 1 to 10, and then this 1 to 21. This is the sharing DP between the 2 track sections. FMA is the name given for the track section. So software for MSDAC, we have 2 types of softwares. One is executive or system software. It says how various parts are operated together, like the data communication, how it takes place, and how the reset and different input card, output card, they communicate, things like that. This is model specific. If one make one model is available that is common for all, and normally it is loaded in the factory before dispatching. Application data is one where the logic is involved in this. What are those inputs which forms a single track section? All that information is given as the input, and how the reset is applied, and from which point to point, which input pertains to the reset of which section. All those things are included, and it is a station specific thing. Reset. Reset is another important feature of the axial counter section, because axial counter is a electronic equipment which can momentarily fail because of the surges or momentary disconnections of the power supplies or things like that. And the power supply resumes, it can't go start working normally. So reset has to be done to that equipment. When we do the reset, what the system assumes is that there is no train in the section. That's what is the reset implications. That is why it has to be fail safe. This is what SCM of Indian Railways says. There are 3 types of resets: preparatory and conditional reset. Conditional reset is nothing but 2 people, when they cooperate and then press the buttons, immediately the section clears. Preparatory reset is the one where when the reset is applied, system says that yes, everything is all right as far as the hardware is concerned, and it is ready to work, but it won't give the output unless one train is passed without signal into that section and clears it. That is the preparatory reset. Basically, the resets, the number of types of resets are available, but Indian Railways have chosen these 2 actually. We can see something like this. There are here almost 7 or 8 type resets are shown: direct reset, restricted reset, preparatory direct reset. Names given are different. See, like for example, in a section, only in counts are there, not a single out count is there, or the last count is not the out count. Then there is a possibility that there is a train inside the section. But still, the system, since it has gone into a fault mode, it has to be brought back by resetting. So the system says that the last count indicates that most probably there is a train inside. That is why more care has to be taken by verifying the records, verifying physically by 1 or more agencies. There is another thing like reset with acknowledgement. Reset is applied, train has passed, preparatory reset. Let us assume preparatory reset. Reset is applied and then train has passed and then it shows clear. Now at that point, is the system asks the operator, would you like to accept this output? What is that output? That section is clear after the passes of the train. Then only it really provides the output. So it involves the operator also, because in case of shunting and other things, there is a possibility for the system showing clear with the vehicles inside. Wheel sensors are nothing but components which receives a AC signal and generates a flux, which is goes around the rail and it comes to the receiver. And from when a train passes over the rail, the flux in the air gets influenced by the wheel, and signal strength at the receiver reduces. This is the same principle. Normally there is a coil and a capacitance is also can be there. This is another type of wheel detection. Same coils are there. And here you can see the phase angle of the receiver is changing. That is received signal when a flux is generated, the flux normally the path is something like this, that the center line of the 90-degree center line of the receiver, if it is the red line, it is passing, crossing over that and then generating the voltage here inside. You see the second diagram. When the wheel is there, the flux takes a different path. That is, it changes to the right side of this red line. Thereby, the phase of the received signal gets changed. So this phase change and amplitude, both the changes are made use of for the detection of the wheel, the passage of the wheel. But this can happen for any other things also, like the small vehicles like trolleys, or somebody is working with a shovel, iron shovel, or the crowbars. The magnetic flux gets influenced. But the thing is, those things are rejected and they cannot cause exactly the same type of phase reversal. That's how the electronics that receives the signal from the receiver decides that it is not a wheel, it is only a disturbance. Thereby, it won't be taken as a count. But if this disturbance happens more often, what is to be done? There is a limit also sometimes. Then the system may go into the failure mode. Then reset has to be done. Yeah. These are inductive type of sensors. You can see the previous diagram. The transmitter and receiver are on both the sides. One side, it is left, right side, one is the sender, left side is the receiver. Receiver is inside the track. You can see the wheel passing and cutting the flux. In this, both transmitter and receivers are provided only on one side. There is nothing on the other side. And you can see how the wheel is influencing the flux lines. Here, the basic principle of working is the transmitter sends a signal. You can see this. Imagine that there is only one of them, not both. Let us say transmitter is sending the signal, and it is, let us say, 21 kilohertz or 50 kilohertz, whatever it is. And these L and C, that is the inductance and capacitance, is chosen in such a way that it offers the least resistance, that is a tuned, what we call it. When the wheel passes over it, the inductance, it influences the inductive circuit of the transmitter. Previously, when the circuit is tuned, the components are tuned exactly, the current flow will be maximum because it offers minimum whatever is the resistance or inductance, impedance. Now, when the wheel passes over that, like this here, it is interfering with the inductive circuit of the transmitter. Thereby, the current reduces because the impedance increases. That is the basic principle of this type of sensors. Now, I think today only Flasher is offering that. Gigitronics has developed. I think they are trying for the approval. So now we are going to look at the various other features of the MSDACs, how they are differently designed, different makes. So electronics is required at the wheel detection point to generate a count. Now in this, we can't say there is no electronics. Entire electronics is embedded inside the signal generator, amplifiers, then again yesterday we have seen the pulse recognition and then counting, including the modem. Whole thing is packed inside. It cannot be said there is no electronics inside. There is electronics inside this. So embedded in the sensor package, electronics entirely is embedded in the sensor package and fixed to the track, just what we have seen. And the second type is what we are talking about, the electronics at the track side. Embedded in the sensor package, fixed to the track and at central evaluator, both the places. Electronics is at both the places before it is given to the evaluator, that is the processor. And there is a third system where the entire electronics is available by track side. Nothing is available at the central place. And the fourth one is by the trackside box and at the central evaluator. That is here, the sensors are simple coils. They're all passive things. There is no amplifier, nothing is available. Whole thing is fed from the trackside box. So trackside box and inside the sensor package. These are the differentiation. Coming to the architecture of the evaluators. Now, signal processing and counting and data processing is done at two places. One is at the wheel sensor, other one is at the central place. Now this is for the wheel detector electronics. Normally 2 out of 2 is adopted. So 2 out of 3 is not adopted at this place. Sometimes you can order for hard standby of 2 out of 2. The third one can be there. So 2 out of 2 says that it is only for the safety purpose, whereas 2 out of 2 with hard standby is for the reliability also, both. As we see the different makes of the MSDACs, you will be seeing these differences actually. Like this here, how their electronics is distributed, how the architecture of the processor at the detection point is there. Input cards at central evaluator. Do we require input card? There are no separate input cards for some models, only completely combined with the evaluator module. They call module, card, board, PCB, they're all same. 1 or 2 DP inputs per card. There are input cards. They take about 1 or 2 detection points, inputs counts that are coming from the field are taken by this input card. And there are some which takes multiple DPs inputs. 8 DPs inputs are taken by a single card. So no input card, 1 or 2 inputs and multiple inputs. 3 varieties of input cards. Output cards. Again, there are no output cards in some cases. They are combined with the evaluator module. And some places they are 1 or 2 outputs per card are given. And there are some cards where multiple outputs, like 10 outputs can be given by a single output card, depending on the model and make, as we see. This is the architecture of a central evaluator. Here also the same diagram what we have seen previously. 2 out of 2, 2 out of 3, 2 out of 2 in hard standby. This is the third one. So all the 3 models are there. Most of the things are nowadays 2 out of 3. And there are many with just 2 out of 2. without hard standby also. This is what actually input cards and architecture when you have seen 3 models. Common processor for all track sections. Now coming to the processor cards. What we have seen is the architecture of the processor cards. Now let us say multi-section digital axial counter takes care of, let us say, 40 DPs and some 40 outputs, 40 track sections. How many processors are such 2 out of 3 processors are required to process the data? Is it possible with a single processor or more processor units are required? Unit, when I use the word, all the 2 out of 3 together is a unit. So is it possible to do it a single unit or multiple units are required? That depends again on the manufacturer. This is what we are discussing here. So if MSDAC type 1, here it is only centrally, just only centrally means we are talking about central evaluator only. At central evaluator, only one set of 2 out of 2 or one set of 2 out of 3 processors are sufficient to process all the inputs and then give the outputs. The example is the Thales. And there are some, that is type 2, that there is a separate input card, a processor unit and output card. Processor means it is 2 out of 3, not single processor. This entire thing takes care of maybe 1 or 2 sections. Similarly, this second one, third one, fourth one, fifth one, like this. Then common processor for a group of track sections. Let us say for about 8 sections, 1 processor unit, like that also can be there. So there are 3 types of models. And data and power. That is, data is exchanged between the electronics at the detection point, wheel detection point, and central evaluator. And the power is required at the detection point from the central place. This is the condition to be met. So data can be taken in 1 pair of copper cable or 2 pairs of copper cable or 2 dark fibers. 3 models are there. And power supply also, it can be shared by the same pair of cable. Just 1 pair of cable can bring the data from detection point to the central place, as well as the same communication cable can carry the power from central place to the detection point. This is called coupling. So shared by the same pair of cable. Second one is provided locally. Locally, a bus bar is run and then provided at the detection point. Then sent by a separate pair of cables, conductors from central location. Within by the data logger system itself, like 1 quad is laid between evaluator and a detection point. Out of the quad, 1 pair is used for power and other pair is used for the data. So these are the models available. Just diagrammatically I have shown it. So you can see there is a digitizer and then there is evaluator. Digitizer means actually data only flows here. So there are 2 pairs also. This is another model. And the entire electronics is available or whatever electronics is kept inside the DPs. The 1 pair and 2 pairs system are available. This is how a PDC works. You can see, and this is for CEL SSDAC, where about 96 volts DC is applied to this unit, and also some 2 wires are connected to the evaluator modem, and just 2 wires are connected, 1 pair of quad cable to the field unit. DAC, digital axial counter field unit. This is the electronics at the site. Now power and data coupling unit, that is the name of this. So here we have given the power input and 2 wires are connected to evaluator. At the far end, these two terminals gives about 70 or 80 volts power supply after the voltage drop. And similarly, this can be connected, two wires can be connected to the modem of the field unit. So the modem of the field unit sends the data like this to the evaluator, and the power also travels like this to the DC-DC converter of the field unit. So that's how the power and data is happening in the same pair of the cable. This is how the local power is provided with two wires as well as four wires, both are there. In this, there is a consideration, there can be a compromise in the distance between these two, evaluator and the DP. 4 to 5 kilometers is the maximum normally taken to like when you follow this. If you want to take it more kilometers, like 15, 20 kilometers, then you have to provide the power locally like this. Then the range can be increased from 5, 6 kilometers to 15, 20 kilometers. This is what we have talked about till now, the general features of the MSDACs. Now we are going to look at each make. We'll be covering 7 makes. 1 or 2 I have covered it more detailed way, and others I have just given some information so that the time is saved for you, and then the features, basic features are brought out. This is MSDAC of Fracture, FADC release 2, Fracture's Advanced Counting System. For this, there is outdoor, only wheel sensor is available. 5 meters, 10 meters, 15 meters length, these things are there. And in the indoor, there are just 3 cards, AEB evaluation card, communication card, and input-output extension board. This is also card. FDS is about the fracture diagnostic system, which gives the diagnostic data through a port, which can be connected to a PC. Reset box and LV box are common for any make. So there is nothing special about this, even though I am mentioning here, they are just similar. Actually, the features are these 2 out of 2 architecture. Central evaluator is 2 out of 2 architecture. No outside electronics at the detection point. It's only entire electronics is kept inside the packing of the detection unit, detection sensor. A single card, AEB it is called, it takes the input, processes it, and provides the output also. It takes the input not from one unit, but number of units. That's how track section is formed. So input, when I said more number of inputs from other AEBs also. Output delivery is data through a data, it is done through communication card. And if you want a relay interface, it is the IO EXP card. So this COM card does many things. Out of that, giving the vital output in the form of data is one of the jobs of the COM card. If you are giving IO EXP card, do you require COM card? Still you require it because it does other jobs also. Power supply 19 to 72 volts and capacity. They are made for wide variety of power supplies, these MSDACs. Capacity is given not in terms of track section or detection points. It is given in terms of number of AEBs, COM boards, and IO boards. AEBs communicate with each other in CAN bus. You will be able to appreciate it when I show the diagrams a little later. And these COM cards, communication cards, they communicate through Ethernet. One track section can you can constitute one track section with a maximum of 16 dBs, even though it is a very rare thing in India, but it can be done. Wheel sensor looks like this. It is a clamp type. It is clamped to the base of the rail. No hole need be drilled. This is another advantage of this. The clamp looks like this, or claw looks like this. And this is the unit actually, this is the cable. Name is called RSR 180. What is there inside RSR 180? A chip, few chips, maybe some little coil or capacitors, all are electronics, embedded type or SMT type. And then maybe an amplifiers. And then you have a modems also to send the data through this cable. The entire thing is packed inside here. Electronics is available inside. This is trackside connection box. It is nothing but a terminal box actually, nothing, there is no electronics, nothing available. And this is actually the dummy wheel, which is used for simulating the movement of a wheel over the transducer. The cards looks like this. This is the processor card, AEB. This is the COM card, which is one of the jobs is giving the data as output, and other things also there will cover now. Then we have power supply card, then IO card, that is the input. This gives the output in the form of potentially free contact to pick up a relay, and it takes the inputs also, because when you are doing the reset, we said I said it you have to connect potentially free contacts, wire the relay contacts or the button contacts. All those contacts are wired to the IO board only. Equipment looks like this. You can see, you can recognize the cards. This is the AEB card. You can see system 1, sys1, sys2. This is 2 out of 2 principal. And this is another card for the DP2. And these things you can see IO board, IO extension board. And the card which is connected with the number of cables, this is the communication card. So here in this board, we are able to see 1, 2, 3, 4 IO cards, IO extension cards, which provides the outputs and takes the input for reset. And then 1, 2, 3, 4 sets of AEB cards. You can see 1, 2, 3, 4, and there are 2 COM cards, or 3 COM cards. Third one is here, not visible inside. Now let us look at how these different subsystems are connected. RSR is the name given to that sensor, wheel sensor, where complete electronics and sensing thing is available. This is the track section to be monitored, FMA1, and there are 2 wheel detectors on either side. These 2 GAKs are just the terminations, and the 2 wires are entering from outdoor to indoor. And this outdoor to indoor, it can be about 4 to 5 kilometers. No problem, it can be connected. And then this BSI is the one which is protects the internal electronics from the surges and other things. AEB is the card. I said there is no input card in this. Directly, it is connected to the AEB card. And the IO card is the one which provides the potential free contact as output and takes another potential free contacts as input for the reset. So it can be available on both the places like this. Output can be available at both the places. How the AEBs exchange the counts? like this. When the count occurs here, it receives and then it sends to the other AEB. Similarly, the count happening here is exchanged like this. Is it not looking like a single section digital axial counter? It is exactly the same. This AEB IO can be at one station. This AEB IO can be at other station. Or and at both the places you get the relays. But this COM card is required for some other purpose. We will also see what it does. Here you see the difference between the two is that there is no IO card here. That means the exchange of the wheel counts are taking place between the two AEBs and they are giving their output. And that output is given to the same CAN bus. This is CAN bus actually, to the COM card. And COM card through its Ethernet port gives the data. The data of section FMA, occupied or clear. So when this COM card gives to electronic interlocking data, if it has to take place in a fail-safe way. And this is a very difficult thing. This design has to be done separately with each type of electronic interlocking. When I say that this particular axial counter can give the data in a fail-safe way, the other unit shall be able to take that data in a fail-safe way. That is important. Protocol is the thing. For that purpose, Froscher has developed a protocol. They say the Froscher fail-safe protocol. And if the same protocol is followed by the user, then they can get it easily. But normally, it may not be possible. They have to receive the data in a fail-safe way while modifying their protocol. That is required. So again, what is the functions of AEB? This is evaluation of one wheel sensor. That means each DP requires one AEB. And it can provide two track sections, clear or occupied status. Then direction of movement also it can give. This is another benefit of the Froscher axial counter. It gives the direction of movement. Section DPs can be used for a single section. This AEB is getting the data from one DP, which is connected to it, but it can exchange the data from 15 other DPs to form a section, a single section, track section, whose occupancy can be approved with these 16 DPs. COM card. It forwards the wheel sensor data in Ethernet to other AEBs. This I will explain to you a little later. The read and provide the configuration data to AEB, because the configuration, that is the logics are to be planned. These logics are entered through the COM card. The PC is connected to the COM card, and then that it pushes the data to AEB. Just we discussed the section clear data, it can send to EI. And then it gets the diagnostic data from the AEBs and EXBs and its own diagnostic data, all the three, it pushes to the hardware called FDS, Froscher's diagnostic system. IOEXP, it gives a fail-safe output for two sections. That means 4 potential free contacts, 2 for each input output. It takes inputs of resets as potential free contacts it reads. It displays error codes of AEB. Axial counter status also it displays. Then it can work as a MUX, fail-safe data transfer of 12 digital inputs. I will show you how it is configured. This is the AEB card. You can see 2 out of 2. This is the one processor. This is the other processor. And calibration. If you remember initial days or even some of the present axial counters, the data at the input card, the value of the sensed voltage that reaching the central place has to be adjusted by operation of a potentiometer with a screwdriver or whatever. Now that has been made actually atomized here or semi-atomized after installation of the wheel detection unit. Then here you can see there is adjust. There is a button which can be taken to the left side or to the right side. By taking to the left side and then after waiting for a few seconds, bringing to the right side, automatically the levels are adjusted by the AEB card itself, irrespective of the distance of the DP. DP may be 500 meters, 1 kilometer, 4 kilometers, 5 kilometers, but that adjustment is done automatically. No need to use meter or things like that. Basically, it is the current actually which is measured to check the presence or absence of the wheel, as I was telling. The current changes from maximum to the minimum when the wheel is present at that point. So measuring of the current requires disconnection of the wire. That is why what they have done, they have terminated 100 ohms resistance in the series in the circuit, and they brought it here into the 2 terminals. And here you can just keep a meter in the voltage mode and then measure it. So if it is 2 milliamperes, it is supposed to go 200 millivolts. 5 milliamperes, 500 milliohms volts. So the measurements are made simpler.
Sir, can we have a 5 minutes break here, please?
Yes, I thought of asking.
No problem. We'll assemble again after 5 minutes. Now it is 2 minutes to 8. We'll assemble at 8:05.
Yeah.
Right, sir. So all are requested not to log out. Kindly be waiting, and we'll be resuming again after 5 minutes, please. Sumit, would you like to announce the date of exam? Just tell hello, Sumit. Sumit. Yes, Sumit, you can.
Thank you, sir. Thank you. So I have an important announcement to make today. Is that yesterday I had mentioned in the chat that this entire 2 days training is free. Yet, if anybody is interested to get a certificate, we have organized. We have planned an assessment of on these topics with about 50 MCQ, multiple choice question based assessment, which you can take in next 15 days. And if you qualify that assessment with a minimum of 60% marks, Railway Academy will award you a certificate of completion for this training. So this certificate can be used by you in the industry, in your career growth, and to establish that you have successfully completed a training and have gathered the necessary knowledge related to the subject. So all those people who are interested to take up the assessment and get a certificate, I will be mailing you the recordings on your email ID through which you have registered for the webinar, along with the details of the assessments and certificates. So there is a nominal fee that we are charging towards the management of the entire exercise. So the nominal fees for that assessment is rupees 1,000 rupees, 1,000 plus GST. So this is the fees that you have to pay to do the assessment and get a certificate. So all those people who are interested can contact us on our email ID or reply on the email that we'll be sending you shortly by tomorrow morning, perhaps. So thank you so much for participating in this training. We look forward to organize many new trainings like these in future. So if you have any questions, you can please raise your hands and I will unmute you so that we could take up those questions in these 5 minutes break, and then Samir Reddy sir can resume the session. So, okay. So let me see. Okay, Zuhair Hashmi. Okay, please, I'm unmuting you. Please ask your question.
Sir, I had paid the registration fee yesterday and the
Yes,
GST was 180%.
So we have received your fees yesterday, Zuhair.
Yes.
So our team will contact you tomorrow to give you more details related to this.
I mean, I think instead of paying 1,180, he has 2,180. Am I
Yes,
right,
yes.
sir?
Yes, sir, 2,800.
Yes, we will refund you the excessive amount. Don't worry about it.
Okay, okay.
So if you
Thank
want
you.
to donate to Railway Academy, we don't mind, no problem.
Okay.
Thank you.
And so tomorrow onwards, we'll be starting the designers course. Already 25 people have registered. Another 5 seats only are left over. If anybody is interested to join the designers course of 42 hours, including the AutoCAD and MacroStation, they can send a mail to Sumit, inquiry@radioacademy.com, wherein we'll be able to give you the entry for the designers course.
Sure. Thank you. So, so there was another person who had raised his hand. Was I think
Ravi Sharma.
Ravi Sharma. Yes. So Ravi, so you can ask your question, please.
Hi. Actually, I wanted to inquire about this course, the signaling design engineers.
Okay. So Ravish, I'm mentioning my WhatsApp number in the chat box right now. Please WhatsApp me on this number, and I will take it up personally, one-on-one with you. Right? Is that fine, Ravi? Ravish, are you? Have you got my WhatsApp number? Yes. Please contact me on this number, and I'll speak to you separately. Right. Anybody else who would like to ask any question? Okay. Subir Basu. Okay. Subir, please unmute yourself.
Okay.
Yes.
Actually, I am just hearing these things more as a retired person in appreciation of the entire thing that is being done. I'm really very impressed that you all have organized all this and you are doing all this class and taking signaling, rather multiplying signaling to people other than railway people. Now, I have one only question to ask. So much has been talked about axle counters. So much has been talked about track circuits. Now we know that track circuit is, in a way, today you see you have to replace equipments when you improve the signaling. And in track circuits, you know, it's possible to do it on a building block principle and expand it to higher levels of signaling. Unfortunately, that disadvantage is there with axle counter, though it has many other advantages. Is there anything thought about by any systems anywhere where information in the track to train direction is thought of so that expandability of signaling to, say, let us say, cab signaling and all that is done? Is there anything where axle counter has been pursued in this direction or thought of being pursued?
Thank you, sir.
Thank you, sir, for your excellent question, a beautiful question. We also thank you for appreciating the lead we have taken in hosting this webinar. Mr. Sami Reddy will be answering you this question. I hope he's a competent person to answer your question. The moment he joins, you can ask your question, no problem.
Okay.
Where
I
you are,
think,
sir?
I am already there.
Sir, Mr.
Over to you,
Subir.
Dave. Yeah. Actually, how the modernization of railway signaling is taking place is something like everything is going on wireless. The presence of the train or the track section clearance and all, even axle counters are not required when we go for what we call it ETCS3, European Train Control System. Most of the train control systems are developed in Europe, and that model is copied by the developing countries, and they are becoming almost the standards. ETCS1, ETCS2, ETCS3. These are the three levels today, train controlling systems. ETCS3 actually, ETCS1 protects the train when it jumps the red signal. ETCS2 completely we can get rid of the line side signals, but still train detection is there. In the third one, the train detection itself is removed actually. So this is the how the development is taking place. But axle counting or whatever we may call it, using the sensors by the side of the track or on the track or rails, that is there is a lot of scope is research is going on. Some products are coming out, like for example, precisely where the train is, it can be found out by optical fiber cable, burying optical fiber cable just a meter away from the track, and any wheel problem or the rail problem by acoustically or by vibrations sensing the difference. Even somebody is walking by the side of the track, it is possible to find out like that. So the research is going on in that direction, and then some products are coming out. So track circuit is on its way out, but still not completely, because it is such a simple system. It is more than 120 years old actually, but still.
Can I elaborate my question a little more?
Yeah.
You see, the basic point is you have to consider a track which is like a mainline track or a trunk route track, and there are branch lines always. Now, you cannot have ETCS everywhere. It will be normally limited to where there's high traffic. Where the traffic is low, obviously you will have track circuits still remaining or axle counters.
That is taking place. Yes, in fact, it has to be done in the same way. In that context, actually, the DC track circuit, things like that, they are going to remain for time to come.
No, what I'm trying to say is that since we cannot afford to put branch lines and the non-important lines upgraded to ETCS, this and the fact that we have really not got into the issue of cyber crimes on wireless, which is bound to affect train operation, or a lot of work has to be done to protect train operations. It might be a thing that people might have to think more either in improving it or even staying a little more with the conventional thing and upgrading it. That is what I was thinking.
Yeah, sure. Definitely it should happen. Like ETCS, because it is a more costly thing, like in India, we started developing TCAS, we call it. So like that, definitely efforts are being made. Yep. So,
Thank
Okay.
you. Thank you,
you.
Mr. Basu sir. Thanks a
Thank
lot for your beautiful question, very encouraging question. Sir, you can continue, please.
yeah. So we have just discussing the Froscher's axial counter. So there are three functions by the IO EXP board. That is axial counting output it gives, and data transmission and counting head output. Counting head output is about the direction of travel. So you can see here one AEB and the number of almost 8 EXPs are connected. Some are used for axial counter output, some are for data transmission and counting head output, like this. So the design depends on what we really require. It is almost the design required for the MSDAC involves, it is something like a electronic interlocking to that level. Yeah, this diagram shows the 5 sensor units, and then 3 sections are shown. In fact, one more sensor is required for FMA2, it is not shown here. So there are 5 AEB cards, 1 COM card, and all are co-located in the same box. This is called central architecture. And there is a software interface because there is no IO boards here. You can see this. This is a decentralized architecture. Let us say the distance between this RSR1 and RSR2 is, let us say, 10 kilometers. This is at one station, this is at other station. And these COM boards and AEB are at one place, and this is at other place. And both are connected by, let us say, OFC cable or by E1 channel with the Ethernet interface. Then you can see here, this is another unit within the station, and each sensor is having its own AEB and also the IO card, that means output it can give. For example, FMA2 output we can have from AEB, this AEB, first one. By taking the wheel sensor, the wheel count data through the COM card like this, back here. So the AEBs exchange their counts in the CAN bus like this, or if they want to take it from the adjacent units, they go through the COM cards. This is through the Ethernet. And diagnostic system is given here. The COM cards are all connected to the central diagnostic system. I think this gives you a fairly good idea. There is another feature in this. This is called counting head control. For example, there is no train at all in this whole section. And if RSR4, somebody has gone and he is doing track maintenance and his shovel or whatever it is interfering with the wheel flux, then that data is processed by AEB. And then it has to decide whether it is a wheel count or not. And then there is sometimes if it is nearer to the wheel count, then it will count it as 1 and then it fails. What they have done is when RSR 1, 2, 3 or 6 or 5, none of them have started counting. RSR 4 and RSR 3, these things can be made inactive. Inactive in the sense that the signal is not processed in the way that it is taken as a fault. So when RSR 6 started counting, immediately this is activated, RSR 4. This is the feature available. Then additional output from MSDAC we can have, as I was telling here, that condition of the counting head output, counting head direction of travel we can get. That can be used for the purpose of route release, the direction of the movement of the train. So these are the different things. This we have already seen how sections are formed. And this is another application. Let us say a 3-road station with about 12 wheel detectors, and then 9 sections are connected in this way. That this line is the border for the outdoor and indoor. All these are kept in the same room, same rack, COM board, and all the AEBs, BSIs. And these are all the one quad is laid between the wheel detector and the central room. This is for auto section. You can see here that ZP5 and ZP6, this forms a section FMAA 4. This is a track section. So this counting is taking place by ZP5 counting unit is at AEB, and then ZP6 is at the other AEB. Both of them, they exchange through the COM boards like this. And this can be dark fiber or E1 or any media, communication media. This you can see, like this is one station, this is the other station. So we can take as if this is the advanced starter and this is near the home signal, and both the COM cards can be connected by a U1 channel to exchange the status. At both the places you will have output section clear indication. This is a block section. In the same way, all other AEBs, they detect the other sections. This indoor and outdoor is wrongly written here. So this is also like end gumtis. If a station has end gumtis, you can have one unit at the one end and other unit at the other end, and the COM cards can be connected like this by dark fiber or the cable. This is how the connection takes place. Just I think this may not be required, but some people who are interested, like power supply is given from the central place through the protection unit through wire numbers 3 and 4. This is the power supply wires. And there are 2 wires, system 1, system 2. That is 2 sensor wires. They reach to the central place like this. And they are processed here. So the RSR 184 wires are like this. All these diagrams I am showing that so that you will have the feel of the equipment, and then when you look at the manual, it becomes easier for you. This is the cable that is coming from the central evaluator. This is the location box. That yellow box, what I said, simply it extends 4 wires to the RSR 180. Now, this is the example how where IO quads can work as a fail-safe muxes also. Here you can wire the inputs and you get the outputs here. Similarly, inputs potential free contacts, you wire here relay contact to this IO board, you get the contacts here. Only thing is each IO board can give only 2 outputs. So if you want, let us say 10 or 12, most probably more number of things have to be connected. So these are all for troubleshooting. I think they are not that. But logic, that is diagnostics, are provided by the IO board. It gives partial traversing of the, that is during shunting. If one wheel occupies only the one wheel sensor, then it gives only 1 pulse. So such things are all indicated at the IO board. This is the reset box. There is an SM key and then button. There is a reset counter, and then you have all those line verification, and then preparatory sets changed or not, section occupied or clear. These are the normal indications. These are all standard for any product as per the Indian Railways requirement. This is the one which gives the diagnostic data through the Ethernet port. You can connect a PC and then with their software you can view it. Maintenance, actually you can see all European products, they normally don't require, as per their conditions there. They say that 1 year they have to do some mechanical and visual inspection, or even the readings what they have to take. But in India, maybe we have to do more checking because of the vibrations and then influences of the electromagnetics and other things. So this is end of one of the products. This is the second product is the Siemens. It is ACM 200. So this has a trackside equipment, ZP D43 is the name. There are 3 versions for it. One is standard, that is each electronics in the provided at the site. It has, it can give one output. This is a double usage, double output it gives. And then it is external supply it takes and then gives the double usage. Similarly, track sensors are there. And there are transformers actually here. If the noise is there between, if the noise is there in the cable, because it is a copper cable, they provide isolation transformers also to reduce the noise. So the indoor equipment, it has ACM 200. This is the only card actually. Otherwise, there is an Ethernet switch and then ID plug is plugged to this ACM. Reset box and all, they're all common for any thing as you have seen. So outdoor equipment looks like this. This is the wheel sensor, but we have shown only one side. The other side also is there, which is like this. There are 2. One is transmitter, other one is a receiver. And there is electronics in this box like this. So this model has a trackside electronics. And this is the evaluator. You can see this is the switch, LAN switch. This is the power supply. And this is called ACM 200. Takes care of 2 sections. There are 2 such evaluators you are seeing here. So these are the parts as we just shown. This is the switch, power unit, ACM 200, and the ID plug. ID plug is this actually. This ID plug has the information pertaining to the particular this ACM 200. Yeah, the principle of working is same, that wheel influences the magnetic flux. And the circuit is something like this. It sends 43 kilohertz signal to the 2 transmitters, and then receiver. This is the trackside electrons, what you are seeing. The receiver, you receive the response, filter it, amplify it, rectify it, and then convert it into a frequency. And then send it to the central place. Because frequency won't get influenced by the outside interference, whereas the voltage value gets influenced. That is why voltage to frequency conversion is done. And axial counter computer is the central evaluator actually. This black box, this one. So one ACM can monitor 2 sections, and one DP input directly it can get. That means it controls one detection point. And but it directly it can be connected to 2 that is the detection points. That is DP input directly that it gets is from 2. And it can get from 8 other remote detection points through the switch. Because if you look at this diagram, there are 2 of them. Each one can control 2 DPs, 2 plus 2, 4. All the DPs connections are done into this switch, LAN switch, and they are connected to the processors here. So they can connect, they get the data exchange through the LAN switch. So this is the configuration ID plug actually. This is, looks like this. This is when once it is, data is entered inside this, in case of a failure of this hardware, simply you can take out this ID plug and then plug the new one and then plug this into this. So without using a computer reconfiguring the inputs, you will be able to restore the failure. That is the advantage. Quick exchange in case of a failure. There is no need to, because it is a processor inside, gets the data from this ID plug. It looks like this, this unit, this is the backside, these are the ACMs actually. And the capacity of one full rack is 70 DVD sections, train vacation detection sections, 70 sections and 70 counting heads with 35 modules, because each module you have seen 2 detection points and 2 sections they can monitor. This diagram fully explains, looks complex, but I will guide you through just simply. What you are seeing here is 3 ACMs. ACM is an input, output, processing. Everything is done by this one single box, single PC, whatever is available. If you look at this first one, it is connected to 2 ZPs. ZP is, that is a DP, detection points. 43.1, 43.2 are connected to this. You can see this is the mark given 43.1, 43.2. And it monitors train vacation detection of the section 1 and section 2. Where are this section 1 and section 2? This one and this one. How can it find out the train availability in TVDS1? By getting this data. You can see this may be far away. So another ACM is available here, and it is connected through a OFC to the same LAN switch. So the wheel count here reaches like this. Similarly, the purpose of the ACM here is not to generate an output, but simply send the pulse here. That's all. Similarly, these 2, you can see TVDS 3 and 4 sections are checked by this unit, and 5 and 6 sections are checked by this. So assigned train vacation detection system, that is the track circuits actually, assigned track sections, directly connected DPs, 1, 2, 3, 4, 5, 6. You can see 1, 2, 3, 4, 5, 6 here. And X and Y, last ones, they are far away. So they are brought through another ACM here through OFC, through modems, and otherwise through copper cable also through again modems. They're all connected here. And you can see these 3 also with the green wire, they are connected. That's how the configuration is done in such a way that all wheel counts required for each section, train vacation section 1, 2, 3, 4, 5, 6, whichever wants, they get it as per the configuration we have loaded into this. So inputs, you can see here, inputs to these things are marked by this line. The immediate, preparatory, and auxiliary, and resets. Safety related information, that means potential free contact. You want to repeat it from here to here, you can wire the input here to this. That is what safety related information means. Outputs are also like that. Clear occupation it gives. Whether reset is possible or not. If it is not possible, also it gives output. It is not possible. If it is possible, it is done. It gives an output saying that yes, reset is successful. REA. And then safety related information. Again, it is an output. A potential free contact wired here can be repeated back at the station here, like that. So what all I have explained there actually about inputs and outputs, I have only written here. Again, semi-automatic calibration, what you have seen in Frosher is available here. By operating this particular switch, it is possible to calibrate the signal that is received from the detection point by this processor unit. This is how it is done actually. Press it for 3 seconds on each direction. There is extensive diagnostic LEDs provided, each one. Details I am not going to cover, it takes a lot of time. Like this. And these are the output relays. These are the potential free contacts available inside. You can see this is the processor. This is the contact. Normally open, normally closed. Anyone you can choose. So the power supply is given here, and when it closes, power supply applies to this relay. This is the track detection relay, whether the section is vacant or not. You can see both positive and negative side it is proved. This is the battery, positive, negative. Whereas reset restriction or reset acknowledgement. This restriction means that it is not possible to do the reset, it has not accepted. Maybe because last count is not an out count, or not even one out count is there, those conditions. Then reset acknowledgement. Yes, reset has been successfully done. That is also given. Similarly, whether ACM is okay or not, is it under calibration, is it out of order, is also given as a potential free contact. All these things can be wired to, in case of electronic interlocking, all these are given as a digital inputs to the electronic interlocking, and we can display it to the user at the station, feedback of resets and all. These are the reset buttons, inputs. You can see this is the processor portion of it. When this is a potential free contact, like electronic interlocking input, what we wire it, these are the wired contacts wired. Yeah, the maintenance, like previous one, this one also for a year you need not do anything. So even some of them 2 years, but maybe these conditions may not be really. They produce the same manuals prepared in Europe to us also, but for example, grounding and other things, we check every month whether it is there properly or not. The reliability of it, where theoretically they have calculated, one ACM fails only once in 24 years. ID plug, maybe it's many more thousands of years he has given. But there is a statistics are little deceptive. One ACM fails in 24 years. And if I have 24 ACMs installed, every year they can fail. If I have 24 into 12, every month I can have a failure. So that has to be kept in mind. So there are different type of informations given in diagnostic data, like some of them are events, simple informations, some of them are failures. Some failures may require attendance of the persons immediately, some may not be required. So like this, like wheel detection equipment is faulty. Wheel detection equipment or its cable is faulty. Here it is sure that number 8, cable is not faulty, something like that. Now, this is the one latest model released in Europe, which I think Siemens may take some time to introduce in India. This provides the data also directly. So ACM 250, this is the model. So that is the end of Siemens. As you have seen, if you study one of the products with a little thoroughness, all others you can simply compare and then get the knowledge out for that. This is called AZLM. MSDAC, one of the oldest ones, made by Thales, but manufactured in India by Eldine. Part of it is imported, and this is we will cover now. This has the same trackside equipment is the rail contact and electronic unit, just like Siemens, and there are optional equipments, power and data coupling units, and isolation transformers in case of noise. This works on vital computer module 2 out of 2. And it is just like the first model of what I have shown. This vital computer module 2 out of 2 takes care of the entire section, that is entire equipment. There are input cards and output cards. Input card is called serial card. Output card is called parallel card. So one input card can take care of 2 wheel detectors, and one output card can take care of 1 track section. So it is just like electronic interlocking, like processor modules, input cards and output cards. Of course, power supply will be there. So if you have a single rack model, there are 10 IO slots. That means you can keep 10 input cards and output cards put together. They are interchangeable actually. Each slot for the PCB, you can keep input card or output card, whatever you like, based on your requirement. That flexibility is there. If you have 2 racks, you can have 26 IO slots. And if you have 3 racks, maximum 42 IO slots. That means 42 input and output can be connected to this 2 out of 2 architecture. 2 out of 3 also is available, but not introduced in India. It looks like this. You can see this. This is the processor card. These 2 are the processor cards and their power supply cards. 1 is power supply and 2 is the processor. 1, 2, 1, 2, you can see. And this 4 marked is serial card. That means input card. And these are the output cards with keys. This is a particular, they can be interchanged also, positions can be changed. It looks like this. This is the electronics portion of it. Here only 2 racks you are able to see. This is all 3 racks are available here. And this is the relays. Wheel sensors are the most common ones, like transmitter and receiver like this. And this is the what you call electronics at the track side near the detection point. These are all the PCBs are plugged into these things. Without PCBs, this top view photo is taken. It depends on the phase reversal actually, as we have already seen previously. And the input card looks like this and output card looks like this. This one gives you the error codes and all. And this key switch is required for initially to energize, that is the reset purpose. The latest models, they say they have removed the key, only the button is there. So something like this it is. Power supply card, CPU card, power supply, CPU. These are the main things. And these are the input and output cards. Detection points and section outputs. This works on 2 wires. Power coupling unit is used here. Power and data are coupled. The unit looks like this. This is SM's reset box. As I have told, these are very common. All makes it is same. You have a reset button, and then SM's key is available here. This is a counter. Section occupied are clear LEDs. And these 2 are the line verification, whether it is somebody has cooperated or not, and whether the section has reached the preparatory reset or not. These are the standard indications. Diagnostic data, there is a problem for this because it is a very old model. It can give only locally only. Somebody has to take the PC and then download it. This is the output, what I have shown already. Vital relay output is taken like this, 24 volt DC, then first contact, coil, second contact, negative. With this, Thales, we have finished. Now, this is a CEL. CEL also has same wheel detectors, outdoor equipment. There is a field unit, just like Thales. And just like Thales, they have a power data coupling unit. Only 2 conductors are required to connect. And the indoor equipment, there is a central evaluator, and high voltage DC-DC converters are there for sending to the DPs. Reset box are there. These are the wheel sensors. And this capacity is 40 sections and 40 DPs, 40 detection points and 40 track sections. 1 pair. Range of operation is centrally power if you want to send only with 2 conductors, it is 4 kilometers. And if you want to give local power, it can be extended up to 20 kilometers. Evaluator is 2 out of 3. 2 out of 3 means both safety and availability. If one of the processor fails, also system works. There are 5 such sets actually. That means each set processes 8 sections and 8 DPs. That means you can have with a minimum capacity of 8 sections and 8 DPs also this model. This gives you an idea of how it works. DP, and then this is the local electronics, trackside electronics, digital axial counter field unit, DACFU. Then you have this power coupling equipment, 2 wires, and then again power coupling equipment at the central place, data to the module. This is central evaluator. And there are relays. This is the 24 to some high power like 96 volts it gives, so that voltage drop is taken care of. You can see here there are here just 16 units are shown here. Just total 40 can be connected. And reset unit looks like this. And monitoring unit, diagnostics and all you can see. So this is the architecture. It is for 16 DPs. Because it is 16 DP, you can see there are dummy plates here. There are only 2 processor units are there. Each one 8 DPs, total 16 DPs. Yeah, same diagram what you are seeing. You can see the last one. This is the output card and this is the processor card actually. The output card can drive 8 relays. This is also 8 relays. So 8 inputs are taken by the processor card and the output card drives 8 relays. This is the field unit. This is the reset panel. You can see the same diagram what we have shown. First 2 slots are for the power supply DC-DC converters. Then you have a processor and then relay driver taking care of 8 track sections. And this is the second unit. Like 3rd unit, 4th unit, 5th unit also can be there to take care of 40 inputs and 40 outputs. Like this. These are the cards. So the CPU card is something like this. You can see the 8 modems. There is no input card separately in this. If you look at, there is only processor card and output card. EMI08 is processor, relay driver is the output, only 2. So how it is done is that the inputs that are coming for all the 8 DPs are taken care of by the modems which are part of the CPUs. You can see all the 3 CPUs, 2 out of 3 logics. So it is a DC-DC converter. Again, reset panel, we all know the same thing. Reset button is this. So section clear, occupied, or line verification received or not. Has it changed to prepared to reset or not? And then reset counter all are available. These are power data coupling unit at the wheel detection point. Yeah, like this. There are a number of configurations are to be done actually. Yet the dip switches are to be used to configure that each input, and then to which processor it is reaching. We know there are 5 processors, 5 units. So to which one this field unit is going, and what is the field unit number? Because each field unit can be one of the 8, 1, 2, 3, 4, 5, 6, 8. So those are done here. So direction configuration has to be done, configuring. And these are the error codes. Different type of error codes are there. Yeah, like this. Both, this is for the central location and one is for the field unit. So that is the end of the model. CELs. 5th one is for Digitronics. Digitronics also just like the other one, 2 out of 3 logic. So wheel detector sensors are there. There are 2 technologies for it, outdoor equipment. 25 kilohertz normal one, what is used by the CEL. Other one is like Frosher. They have also developed this 1.2 megahertz. They have not yet introduced it. Maybe 4 or 5 months they may take. That one side of the rail only it is kept, and no electronics outside. Electronics is kept inside the sensor itself. So field unit is not required for the 1.2 megahertz one. Same 40 sections and 40 DPs. The DP to central location only 1 pair. And the range of operation 5 kilometers with central power and 25 with local power. 2 out of 3. Same thing, 96 volts. Minimum capacity 8 sections and 8 DPs. It's like this. Yeah. You can see the 6th one is the one at the track side. They're out of the 6, and all others are at the central place. Battery, IPS, equipment room, relay room, then SM room. For doing reset and other things can be done with the computer also, or configurations. There are 2 models actually. The equipment can be provided inside the location box or in a mushroom box, it is called like this. So each DP can be configured to send in a single output. It can be sent as redundant outputs also. That means electronics at the track side is doubled actually here. And there is a third case. You can see this DP40 sends data to 2 central evaluators, because if the capacity is more, then somewhere it has to be shared by the 2, like this. Yeah, this is with mushroom. This thing you can keep it inside like this. These are all how they fix the sensors, the web fixing. And as you have seen, I have told that with the conventional sensors, you require a field unit. With the high frequency one, the electronics entire thing is kept inside itself. So directly it is connected to the evaluator. This is the central evaluator. This is the field unit. Field unit is very near to these 2 actually. Yeah, these are all power supply related. Externally, you can send 24 volts or 48 volts, or with the PDC, you can send the power through the same half quad also. This tells about different configurations how they can be connected. This entire station is connected to one unit. Here you can see it is used at a high availability SSDAC that both the evaluators are connected by the channel, and they exchange the wheel counts of both the ends, and then they generate the output at each place. These are all for auto signaling, the IBS, different models. This is for the diagnostic data actually. Through the internet you can send. This is actually Alt Pros. This is Sigma Rail Systems Calcutta. They are supplying. It is a simple system. There is a wheel sensor as usual, and trackside electronics also is there, and the central evaluator. Its capacity is comparatively less, and it uses only one side unit like this. It is not both the sides, and this is the electronics provided by the track side. And this takes, it is how it looks at central place, central evaluator. There are two units here, not one unit. And you can see the same diagram in a diagrammatic way, that they take about 8 units, 8 dBs it can take, and 6 sections it can give as output. Accordingly, this up is input card, and this RE is the output card. So each one gives 2 outputs, so total 6 outputs, and then 8 sections. As a diagram, if you look overall diagram, it looks like this. This is the central one. What you have seen, this is it here, and 2 wires to each wayside electronics, and 4 wires to that sensors, like this. Yeah, these are configuring the detection points. How they are done, it is shown. They are called H and L instead of AEB channels. H and L, counting direction, how it has to be kept, how it has to be configured, are shown here. These are the jumper wires, J17. Yeah, how they are done at the central place is shown here. So this is the relay output is given to the potential free contacts. It is possible to have 2 relays if required separately. That is track relay clear, track relay occupied. Both it is possible, but because it is a fail-safe product, normally 1 relay is good enough. This is how it looks like if it is applied to a yard, because there are its capacity is limited, only 8 sensor units. You can see how they are connected. And these are the sections, section 1, 2, 3, 4 sections. And the common exchanging one is this. Actually, you can see it is coming here. From here, it goes to the blue one. You can see here, like this. It's connected to the blue. And this, there is a connection between the blue and the green units. You can see here, like this. And there is a connection between the gray and the blue also here, you can see. This one, H4L4, H7, like this. So you have to network, you have to do some wiring for a big yard if you want to provide this. Yeah. The planning has to be done properly, where to exchange the units. They give the error codes also. The last one is of Mela. Yeah, it is also same like other Indian models. There is a detection point at field unit, and then wheel detector sensors, and then center evaluator. It monitors 39 sections and with 40 relays, 40 inputs actually. The equipment looks like this. This is central evaluator, corresponding relays. This is the field unit, and these are the sensors. So 49 detection points and 39 track sections. 2 out of 3 architecture is the central evaluator. In the field unit, it is 2 out of 2. So just 2 copper conductors. In case of OFC, it is only 1 pair. And they are arranged in daisy chain. So I can show you, these are the, it is like this. If it is a copper cable, then this is the central evaluator. They are connected like this, 2 wires. This is the power cable, red one, and 1 pair is taken to the central evaluator. These are the when it is possible to connect wave through OFC also. When you are connected through OFC, the blue thing is the OFC. The media converters are provided at central place and accordingly at the field unit also. You can see the first and out of the 8 units, 8 units is a group. First unit and second unit, DP, can be connected to the evaluator, and in between ones can be daisy chain. It is called daisy chain type of a connection. Like this. Resets, as usual, we have preparatory with line verification, without line verification, and conditional hard reset. And reset buttons and keys are looks like this. So that brings us to the end of the session. I think we can now deal with the doubts or questions.
Yes, sir. Thanks a lot for the beautiful session. Let me take now some few questions here.
Yeah.
Good lot of people have asked some few questions here. How many DPs in EC? Mr. Muhammad Suhail has asked, how many DPs in EC has asked? What is that EC?
EC.
Yeah.
EV, evaluator unit, EV can be there.
Okay.
It depends, like I have shown here in this. 40 DPs and 39 track sections in 1 evaluator unit.
Okay.
It is
Then
like that.
Mr.
I will
Yeah.
show you here. This is the central evaluator unit in this make.
Okay, sir.
And it is able to take 40 DPs and show 39 sections. Now, if you apply this to, let us say, the Siemens or to the Frusher, they are not like this. There are evaluators, central evaluator unit, but there are number of them, that each one taking care of just 2 sections only. So multiplication of central evaluator units will be available in that model.
Okay. One very active member, Mr. Jagdish, has asked to separate the reset box required for all section in Frusher.
Yeah, they require separate, these things are required, but it can be done through EI also. Each section requires a separate reset operation that is required.
Yes, sir. Mr. Hashmi has asked, digitizer work. Is it digitizer work?
Digitizer.
Yeah.
Yeah. Yeah, it is digitizer. Digitizer means it converts the analog signals that are processed, that are available in transmitter and receiver, that is received signal, which is analog signal, is converted into digital counts. It has to say count 1, count 2, count 3. instead of saying that voltage has become 5.5 volts, 6.5 or 0 volts. That analog to
Okay.
digitizer is that.
Okay. Mr. Subir Basu requested for the videos, recording of yesterday and today. Sir, please text to Mr. Sumit your mail ID so that we can send you the recording of yesterday and today's. We really appreciate and thank you for your valuable question what you asked here. Mr. Naveen has asked how PDCU combines power and data.
Yeah, that requires a little more explanation actually. It is something like, you know, you can, if you use a filter, DC can be stopped and only AC signal can be taken by the evaluator on one side. And on the other side, it will not be applied to the field unit.
Yes, sir.
That is how it is done normally.
Okay.
There is a band pass filters or filters, not band pass actually, a filter is sufficient here.
Okay.
And telecom side, if you look at railway, 2-wire to 4-wire conversion units, you can search in the internet also, very easily you will find the diagrams. Yeah.
Okay, sir. Mr. Vinod Meena, again another active participant. Fracture make MSDC works on which frequency?
Yeah, they don't reveal.
Okay.
They don't reveal, but they are at a little high frequency actually. I was told it is maybe about 1.2 megahertz, something like that. Yeah.
Okay, sir. Mr. Srinivas has asked, sir, why AEB card has two sections? Why does those two sections denote? What does the two sections denote?
Yeah, AEB card, SIS1 and SIS2, like thing we have shown. It says, yeah, 2 out of 2. This is one system. This is a 2 out of 2 logic.
Okay.
That is it.
Right. Another question from Mr. Vinod Meena. Can we do reset from Excel counter evaluator in place of reset box?
No,
Okay.
no, it cannot be done. There is a facility for something not exactly reset bypass. That is, if any other conditions are there, the conditions can be bypassed actually. That sort of a thing is available, I think, in Siemens one.
Okay, sir.
Yeah.
Subir Basu sir has asked, in fact, probably one-to-one you can take the discussion, not directly linked with the type of Excel counter. Is there any Excel counter system which, like a coded track circuit, can send information in the track to train detection to make it on a building block principle upgradable to lighter levels of signaling? As I mentioned here, you can take it, sir, as a one-to-one discussion with Mr. Subir Basu, sir. Very interesting question, in fact.
Yeah.
Yeah,
Sure. Yeah, sure, definitely. Yeah.
I hope you may be knowing Mr. Subir Basu, sir.
Yes, actually, I could not, when we was talking, I could not place him actually. Sir, I know him very much actually. He was CST in Eastern Railway and all.
Okay.
I know. I could not place. I never imagined that he will be participating in this. That's why when you said Basu sir, I have not, actually, I could not made out.
It is really good thing that, some such eminent people are attending the webinars, and also we really appreciate their wordings, whatever they are giving their input. Sir, we also request you to kindly come forward to host a webinar on our platform. Mr. Jagdish has asked, can we use button instead of reset box for resetting track in panel interlocking?
Again, please.
Can we use button instead of reset box for resetting track in panel interlocking? Probably what he means is whatever cancellation buttons we are having on a panel, instead of having a reset
Yeah,
box
any
separate-
panel, anything. Only thing is they have just standardized something for approval while the product is getting approved. They
Okay.
have to say that what equipment they are offering for the reset, how it is being done, what is the hardware, their quality, every button, everything they see actually. When RDSO approves for usage on Indian Railways, they look for it. That is why they have to use only those things.
Okay, sir. Another question, sir. My question is that MSDAC system, if a rail break or cut, then section can be detected in case of track circuit case. But is it possible to detect a rail breakage?
No, not possible.
Okay.
Not
Mm.
possible.
Mr. Sukumar Kirar. Shukram Kirar. Kirar साहब आप तो यहाँ आ गए. Okay. What is the method of fixing DPs on girder bridge provided with steel sleepers? OEM by ADN advisor to provide installation between 2 rails and sleepers for 3 sleepers on either side of DP. Probably ensure the proper performance of MADAC being provided on Yamuna Bridge in EDFCC project. As they experience the problems in performance of particular make in Krishna River Bridge. Kirasa, probably you can take one-to-one discussion with Samir sir, that will be better. And Mr. Gajendra has asked sir information about Jagdish has asked again, what are the cable need to be laid from relay room to each detection points?
That is evaluator. Actually, the relay room means evaluator, where central evaluator is available.
Yeah.
From central evaluator, we have to lay the cable. Otherwise, how can we get for example, this one, let us take. This is the indoor, it is set. Indoor means where the AEB is the central evaluator, COM card is the output card. Unless you lay the cable from the relay room up to the wheel sensor, you cannot get the wheel pulse to the central place. Then only you can evaluate them. Yeah.
Sir. Mr. Alivelu has asked where and why IO EXB used.
Yeah, when you want a relay to be picked up, or when you want to wire the input from the axial counter to the electronic interlocking, a potential free contact is required. That is provided by the IO card. And
Right.
similarly, when you are doing the reset has to be through potential free contact that is accepted by it, like this. So for that purpose, IO card is required. You can see the IO card purpose.
Okay.
Fail-safe output and direction travel also it gives in the potential free contacts. Resets, inputs it takes. Of course, it displays the AEB and all, that's a different thing. Yeah.
Yeah, and one more practical question from Mr. Jagadish. Is maintenance-free earthing is required for all detection points?
That depends on the OEM requirements only. Most of the places they are required because better earth is required at each place. Even when you are using the optical fiber cable, you will be using the power you have to send inside. So most of the places they are required.
Okay, sir.
But one thing is, in case of fracture, because nothing is available outside, it's not required. In case of fracture, it is not required.
Okay, sir. Mr. Mustafa has asked us, can you please speak more on maintenance slides of fracture, make MSDAC slides? Actually, I could not catch up all information. Probably, I hope that will be more concerned to particular
there is nothing much. Yeah, nothing much maintenance actually done. Only I have given only some simple things from their manual, actually troubleshooting and all. Otherwise, there is nothing maintenance point of it. There is nothing actually. So some check for the once in a year, they say, you can see. So some mechanical damages, cleaning, things like that only. Nothing much.
Okay. And again, Jagdish has asked, a TPR relay required for all track circuits? Not required. We are not
TPR
providing
means
any track circuits at all here, probably.
no track circuit. They only give potentially free. Track circuit will not be available. So
Okay.
this instead of track circuit, this gives another relay. That's all.
Right. So Mustafa has asked, can you please explain dip switches of Frauscher-based DAC? I hope it will be more in detail probably at this stage.
Yeah, that has to be, you can check the maintenance manuals actually,
Yeah.
the inside, how they, yeah.
Mr. Jagdish, again, another question here. How to reset track if reset box not working in Frauscher? A practical question it is, in fact.
No, that is reset.
Yes, please. I mean, if that reset box is not working, how to
Yeah.
reset?
There is no way.
No way. I hope probably it has to be phased out. Phase. Like
There is no way.
power failure and
See, if somebody wants to do that, it can be done because it is like a failure. In a failure state, if somebody is attending, like for example, relay wiring, there is a problem. We interfere with the relay internal wires.
Yeah.
We replace the relays. Like that, you can give, you can close that contact, whatever this SM key is closing and this red button is closing. These two contacts which are given as input to the IO board, there you short it. If all conditions are okay, it will go into the preparatory reset mode.
okay, sir.
It is
And,
just like any electrical wire, relay wire.
probably if the power supply fades and resumes, and if the battery disconnects and resumes, we will be picking up the ASR with the stick contacts, probably. That will be the way. Right.
Yeah, but these are not that permissive. They won't.
Okay. Yes, sir. Iftar has asked, what is the benefit of MSDAC of in yard where we have track circuits? Probably either we have to have a track circuit or MSDAC, any one, not both.
Yeah. It's a question of a failure, number of failures of track circuits, dependency on the track. It's basic question of why axial counter.
Yes,
Actually. Yeah.
and Mr. Ravi Sharma has asked, I have a doubt yesterday, you said that armor should be earthed at each end. How during field work, someone said to me that if earthing of the cable is done at different earth pits at different location, then a potential difference might be present in the earth pits values, which can cause the current in the cable. I hope
that means, that is the one thing, just earthing of one end or earthing of both the ends. That's the question.
Okay, correct.
Earthing of one end, if you do earthing of both the ends, if there is a potential difference between the earth, both the earths, that will be applied. That is the number one. Number two, if you earth only on one side, how will the current flow? That is going to be difficult. So normally, initially that was the decision, but now both ends are to be earthed. That is the latest decision, as I know. We can refer the RDSO also. Initially, it was said only one side has to be earthed. Now it is actually both sides.
Mr. Mohapatra has asked FADC R2 IS separate relay rack is required for EI, electronic interlocking. I think electronic interlocking should have a separate rack, sir. Am I right?
Need not be actually. They are just the relays. That's all. See, it is a question of picking up of a relay. Okay. With the potential free contact, which is available inside the this thing. That can be kept anywhere. How does it matter? In some of them, they model it like that actually with the in fact, recently at one of the places, we said the no relays are required. Yeah, this is the diagram. Now, you will be wiring your own 24-volt DC, making use of the contact and picking up of a relay. This relay can be anywhere.
Okay.
Anywhere means maybe by the same room somewhere, not too far away, like that. And in case of electronic interlocking, you do not have relay also. You can directly wire these potential free contacts to the electronic interlocking.
Okay, sir.
Yeah.
Selva Kumar has asked, the evaluator will come under which SIL category?
All are SIL4, including input card, output card, whole thing is SIL4. As a system, not as a single independent item, individual item. As a system, processor card, software, entire thing working together, they shall comply to the SIL4. These are the 4 standards which are applied to the system. You can see it is first one is general RAMs, how it is calculated, it says. Software, how it has to be developed, hardware, how should it be, communication, how should it be, all this. Yeah.
Mr. Venkatesh asked, why fraudster actual counter fixed in both the rails in some of the signaling system and some of the signaling fraudsters actual counter fixed on only one rail? What is behind it?
2 rails and 1 rail means I have not understood, but you require
Probably-
only one sensor, only
Yeah.
one sensor unit. If you are providing 2 sensors at the same place, most probably maybe they may be fixing 2.
Mr. Jagdish has acknowledged a very good seminar, a very good information, sir. And is there any separate distance between transmission coil and the receiver coil by Prem Narayan?
Yeah, see, transmitter coil and receiver coil. Huh?
Yes, sir.
There's not much of a choice actually, because it is fixed to the either side of the rail, and if you increase the distance, then it becomes a problem for the, I am only generally discussing, it becomes a problem for the maintenance of the track as well. And so each manufacturer, he decides it in such a way that the proper signal is induced in the receiver. That is the criteria basically when you are using receiver and transmitter on both the sides.
Okay, sir. Mr. Narasimha Rao asked, if it is distributed system, what are the cables to be laid from center to end Gumti for MSDAC?
See, basically, you have to only lay a communication cable to connect both the evaluators, both the sides. In case there are different people, different manufacturers give a different way of connections. So like here, if you look at, yeah, this or even this you can take it as this indoor outdoor is wrongly given, I told you. This is one Gumti and this is other Gumti. Both are connected by Ethernet. So Ethernet, what cable is has to be laid, that standard has to be followed. That means dark fiber can be there. With media converters on either side, dark fiber can be laid. But copper cable is going to be difficult. Copper cable is going to be difficult. Yeah.
Mr. Prashant Kumar has asked, is there any equipment that can provide both axial counter and block interface in block section?
Yeah, these people have developed same fracture, but that is very costly and not introduced much. They have taken RDS approval, This equipment used for data exchange between the stations, basically. I told you. Yeah, this between the two IOs, 12 digital inputs are exchanged. For this application, they have used, not for axial counter. The axial counter anyhow has to be kept normally for MUX purpose.
And
Yeah,
another active participant, Mr. Mohapatra, is asked how line verification box provide outside, visibility wise or section wise?
Basically, physical proximity to the section. That is, you force the person to go nearer to the track where the track section where this axial counter is provided. That is the basic requirement.
Okay, sir. Then Mr. Asar has asked, Mohammed Asar has asked that can we use both track circuits and MSDAC due to water logging on track during rainy seasons? Will it affect MSDAC and can it work simultaneously?
Yeah. They can work parallelly. They can work, and Bombay, Mumbai suburban axial counters are working even now.
I think
That can be
probably in this Ghaziabad, Kanpur section also they have used it. All the three, axial counter, AFDC and track circuit, all the three are working in parallel, if I'm not wrong.
No, third one may not work. Only one track circuit, whether DC track circuit or AFTC, and over it axial counter. Yeah, they are using.
Mr. Vinod Meena has asked how auto resetting work in Frosher make MSDC. Can we explain brief? I hope we have already covered this one, sir.
Yeah.
Of course, that is the end of the question sessions. Thanks, sir. Thanks a lot. We look forward for such a beautiful seminars and webinars from your side. We request you to kindly go with your data loggers and the networking of data loggers and how the data are rather taken into the system. How the data logger will help in fault detecting or maintenance or alerting the people in different ways. In coming days, probably we'll go ahead with that. You can throw more light on that.
Yeah, sure.
Thanks a lot, sir. Thank you very much.
Thank you, everybody.
Thank you. Thanks a lot.
Nice of you.
Guys, we'll be sharing the recording to all the people, those who are registered with us and whoever is interested for the assessment. As Mr. Sumit mentioned, kindly respond to that and you will get a certificate after attending the multiple choice questions based on the 2 sessions, yesterday and today's. Thank you very much.